Good afternoon. Now, new topic is let's get started with logic. Here, logic means crucial for mathematical reasoning, important for program designing, used for designing electronic circuitry. Propositional means here logic is a system based on the proposition. Here, proposition is a declarative statement that is either true or false, but not both. Here, proposition is a declarative statement that is either true or false, but not both. That is means proposition. We say that the truth value of a proposition is either true or false. Corresponding to 1 and 0 also digital circuit. We are using in proposition true or false are using. Otherwise, 1 and 0 also used in the proposition concept. Okay, in next. The statement or proposition game. Here, elephants are bigger than mice. Is the statement yes? Is the proposition is also yes? What is the truth value of the proposition? True. I am taking elephants are the bigger than mice. This statement is a yes. Statement is the correct and the proposition also correct. But truth value also true. Okay, both true. Okay, statement also true and proposition also true. In the truth value of the proposition also true. That is one example. Next one more thing. 520 less than triple one. 520 less than triple one. Here statement is yes. In the proposition also yes. What is the truth value of the proposition is false. Because of 520 greater than triple one is the true. 520 less than triple one is the statement. That's why proposition is false. Okay. Next, y greater than 5. Y greater than 5. Here in the statement is yes. In the proposition also no. Statement is yes. Proposition no. Its truth value depend on the value of the y. But this value is not specified. In the y value is not specified. That's why proposition is no. Statement is yes. We call the type of the statement is propositional function or open sentence. Okay. Statement A, propositional function or open sentence. Okay. Next. Today is January 27 and 99 less than 5. Yeah. This is also one statement. Yes. And proposition also yes. What is the truth value of the proposition? False. Because of 99 less than 5. Okay, na 99 less than 5 is the proposition of the truth value is false. Okay, next. Please do not fall asleep. Please do not fall asleep. In the statement is no, it's a request. It's a request. Is the proposition is no. Only statement can be proposition. Only statement can be proposition. Next. If the moon is made of cheese, then I will be rich. If the moon is made of cheese, then I will be rich. In the statement is yes. Is the proposition also yes? What is the truth value of the proposition? Is probably true. Is probably true. Next, x less than y if and only if y greater than x. X less than y if and only if y greater than x. In the statement is yes and proposition also yes because its truth value does not depend on the specified value of the x and y. Here clearly mentioned x value is not mentioned and y value not specified mentioned. Okay, depend upon the x value and y value depend upon the value that is true. Otherwise is false. Okay. Here I am taking x less than y if and only if y greater than x. Here statement is yes, proposition also yes, but not depend upon the specified value of the x and y. Based upon depend upon the x value and y value. Here totally is the proposition is the true. Next. Combining proposition. As we have seen in the previous example, one or more propositions can be combined to form a single compound proposition. Only single form a compound proposition. We formalize this by denoting the proposition with letters such as I am taking P, Q, R, S and introducing the several logical operators for our logical connectivities. Okay, I am taking logical connectivities or logical operator, both are same. Logical operators and logical connectivities both are same. We will examine the following the logical operator: negation, conjunction, disjunction, exclusive or implication, biconditional. These are the logical operators or logical connectivities. I am taking negation. Negation means it is represented as NOT or symbol. Okay. NOT comma negation symbol. Okay. Both are the negation is valuable. Next conjunction. Conjunction means it is uses the proposition is the and symbol is represented. And and one more thing is disjunction. Disjunction is R is the represented and the symbol is the this way represented. Next, exclusive R. Exclusive R means X over R. This is the exclusive R operator. And implication. Implication means if then. Arrow mark is the represented the implication in the truth value. Next, biconditional. Biconditional means if and only if. And in the double arrow mark is the represented. This is the total logical operators or logical connectivities of the truth tables of the operators. Combine the proposition to the compound propositions. Next, I am taking one example by using the negation. By using the negation, negation means not. Negation means not. Here, unary operator symbol means like this. Okay, I am taking P. P is the proposition. I am taking one statement. In the P value, true and false are there. Here, whenever is true is came, in the negation is going to false. And again, false is I am taking, and true is the negation. These are the negation of the one example. Next, conjunction. Conjunction means and operator is the using. Here binary operator symbol means like this. I am taking two operators. One is the P and one more is the Q. Two variables I am taking. One is P, another one is the Q. Okay, I am taking total 4 rows are there. Y means 2 power 2. Okay, 2 power 2 means two variables are there. One is P and Q. Another one is Q. Okay, another two means true and false. Overall, the 2 power 2 is 4 possibilities are there. Here possibility 4 rows are there. Okay, 4 rows are coming. Here I am using P and Q. P and Q I am why are using conjunction is operator I am here using. That's why here conjunction and P and Q. Here and condition is coming. Here meaning true and true. Both variables are true. Then automatically true is the value. That is the conjunction of the binary operator. Okay, I am taking here P variable and Q variable. True, 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 false, false, true, false, true. Okay, I am taking here true and true. Both variables is same time is true occur. Then automatically value is the true. Okay, that is conjunction. Next, disjunct 2, binary operator or symbol V. Okay, here P and one variable and Q and one more variable. Here I am two variables are I am taking. Here 2 power 2 equal to 4. Total 4 rows are there. Okay, total 4 rows are there. Here I am taking whenever occur one variable is false, another variable is false, then automatically is the false is the final the disjunction of the binary operator. Next, exclusive R. Here exclusive R is the binary operator of the symbol. Here P and one variable is there and Q also one more variable is there. Here same. True and false occur. True and false occur. True value coming. Next, false occur and true occur when our true is coming. Okay, here exclusive are meaning the binary operator of the symbol. P and Q are the true variables. P exclusive are Q. Here the true and false occur true and also false and true occur true. This is the exclusive R. Next, implication. Implication means if then is the represented. Here if then means arrow mark is the represented. Here also same. I am taking two variables are taking. One is the P, another one is the Q. P implies Q. P implies Q means here implies means implication. I am using if then rule. If then rule is I am using, and that's why I am using the arrow mark symbol. Here P is the true and Q is the true occur. True is the coming. Next, P is occur true and Q also variable false is occur. False came. Here totally implication is using whenever P is occur in the true value and Q variable occur in the false value, here my answer is false. That is the implication. Next, by conditional. If and only if. Here binary operator symbol is the double arrow mark. P is one variable and Q is one more variable. P double implies Q. P double implies Q. P double implies Q. Here I am using double implies means by conditional. Okay. Total here true true and false false occur. Then the time only true value is came. True and true occur and false false occur. True value came. Okay, this is about the by condition. Next, statement and operators. Statement and operations. Here, statement and operations are here. Statement and operations can be combined in any way to new statement. Here, statement and operator can be combined. One statement and operator I am combined. Here, taking the new statement. Suppose here I am taking one example here. P, Q, P and Q. Okay, next negation of P and Q. Next negation P or negation Q. Okay, here taking two variables. One is P, another one is the Q. These are the two variables. I am taking P and Q. Here and operation is occur. Here condition is P variable is true and Q variable is true. Here answer is a true. Next, negation P and Q. Whenever is occur true, and then automatically negation is applicable. The time is false. And also false is occur true. This is negation of the P and Q. And one more thing, negation P or negation Q. Negation P or negation Q means here I am taking the P variable. True, true, false, false I am taking. Whenever is true is occur, then automatically negation is applied, false is came. Again, true is occur and false is came. Okay, after that I am apply the here OR operation. In OR operation occur, when OR operation is occur, false, false is occur, then automatically negation P or negation Q is false. This is some example of the statement and operations. Next, exercise. To take discrete mathematics, you must have taken calculus or course in computer science. When you buy a new car from a motor company, you get $2,000 back in a class or 2% or loan. School is closed if more than 2 feet of snow falls or if the wind chill is below 100. Next, tautology and contradiction. Here, tautology is a statement that is always true. That is always true. Tautology is a statement that is always true. Whatever is approved in the tautology is solved the problem. Whenever totally variable is completely last column in the last column, totally true value occurred, that is tautology implication. Tautology implication. Suppose I am example here R negation P and Q double implies negation P or negation Q. Whenever negation is inside is applied, whenever negation is inside is applied, negation P and is R is and. Here and applied, negation is whenever occurred, R is applicable. negation, Q. Okay, next. Contradiction is a statement is always false. Complete column is false. Example like this. R and negation. R negation of negation P and Q double implies negation is cancel P and negation P. And means R is applicable. Again negation P. Okay, here the negation of any tautology, is a contradiction, and the negation, any contradiction is a tautology. Definition. Two propositions of the statements S1 and S2 are said to be logically equivalent. Denoted the S1 is logically equivalent. Here this symbol is meaning logically equivalent. S1 logically equivalent to S2. If they have the same truth table, or S1 double implies S2 is a tautology. Same way, in the equivalence can be established by constructing the truth table using the equivalence class table. Here some formulas are there. Here equivalence formulas. Here first one is identity law. P and T is occur is equivalent to P. Here true means value is 1. That's why I am taking here P. Next, domination law. Here P and F is applicable is equivalent to false. Next, idempotent law. P and P is occur is equivalent to P. Here means two variables or three variables, both variables are same, only single variable I am taking. Here three variables are there or four variables are there, two variables, same variable is there, where occur, and that time is only one variable is taking. Here also idempotent formula, P and P is occur is equivalent to P. Next, double negation law. Negation of negation P is equivalent to P. Next, commutative law. P and Q equal to Q and P. And in the reverse, P and Q is occur, Q and P. Symbols is no change, just variables are exchanged only in the commutative law. Next, associative law. P and Q and R. Here P and Q and R means A and B and C like that. A and B and A and B and C. Same here also associative law. P and Q and R is equivalent to P and Q and R. Next to distributive law. Here distributive law means P and Q or R is equivalent to P and Q or P and R. Here both are differences. One is associative law and distributive law. Only major difference is P and Q and R. Suppose I am taking P means A value, Q means B value, R means C value. Okay, whenever occur, A and B means P and Q. Same here also distributive law. Distributive means P is Q one type and P is one more time is R. Is occur. Here P and Q R is equivalent to P and Q or P and R. Next, De Morgan's law. De Morgan's law means negation of P and Q is equivalent to negation P or negation Q. Ante here means here negation is inside is applicable. Here negation is inside applicable. Here negation P and means R is symbol applicable. Whenever negation is applicable, at that time is negation means whenever negation is applicable, and means R means and. Okay. Here De Morgan's law, negation of P and Q is equivalent to negation P or negation Q. Negation P or negation Q. Next, law with implication. P implies Q is equivalent to negation P or Q. These are the total equivalents. Next, universal quantification. Here I am taking letter P of X be some predicate propositional function. Universally quantified sentence means for all X in the universe of the discourse, P of X is a true using the universal quantifier for all. this symbol is represented. Okay, total quantifiers, there are two things. One is universal quantifier, one more thing is existential quantifier. One is universal quantifier, another thing is existential quantifier. Here I am taking about universal quantifier. I am taking one example here. Let the inverse of the discourse be all people. I am taking UMBC student means S of X is treated and G of X means X is a genius. I am taking one example here. Here what does means? Here what does means I am applying the universal quantification. I am applying the universal quantification. For all X, S of X implies G of X. Means universe of the discourse all people means X is the UMBC student. 2. X is the genius. If X is the UMBC students, then means whenever implies symbol is occur, then automatically then is the like this. Okay. If X is a UMBC student, then X is a genius. ORR. For all symbol I am using means all UMBS students are genius. Okay. Next. One more thing. Existential quantifier. There are quantifier two types. One is universal quantifier. That one is previous discussion. Now existential quantifier. Here existential quantifier means P of X is a UMBC professor. Next G of X is a genius. What does is occur here? There exists X, P of X and G of X. Means there is an X such that X is a UMBC professor and X is a genius. For at least one UMBC professor is a genius. Okay. Next. Negation. Here negation I am taking one example. Not all roses are red. Negation for all X means I am taking not all means. Not means negation is applicable. Negation for all X, rose X implies red X. Existential X, rose X and negation red of X. Means here not all means some is there. That's why I am taking this representation. Nobody is perfect. Nobody means someone is perfected. Nobody is perfected. Negation E of X person. Total all persons are there. Nobody is perfect means there exists negation, there exists X, person or X and perfect X. For all X, person X tends to negation perfect X. Okay, this is about the total of the nested quantifiers.